All right, this is page 7 of the note spiral, and we're working with simulations. And again, this is page 7, and we're actually going to run through a problem. Now, I'm going to admit that I debated about this and decided that I'm going to go ahead and cheat and use one that I've already pre-printed so I can speed things up as I talk. But I will show you how to run the simulation step by step and show you all the things that you need to have. So, the scenario 1, every Monday a local radio station gives coupons away to 50 people who correctly answer a question about a news fact from the previous day's newspaper. All right, so we have 50 people that are getting these coupons. The coupons given away are numbered from 1 to 50, with the first person receiving coupon 1, the second receiving coupon 2, and so on until all 50 coupons are given away. On the following Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement until the total number awarded first equals or exceeds $300. That's kind of important. So they're gonna continue drawing until we meet or exceed $300. If selected, coupons 1 through 5 each have a cash value of $200. Coupons 6 through 20 each have a cash value of $100. And coupons 21 through 50 each have a cash value of $50. All right. So basically, I'm going to just summarize the story that I just read. And the story that I just read was people call into the radio station. If they give a correct answer, they get a coupon for a drawing. They have 50 people who are going to get coupons. They put those 50 in a hat. If you draw their number, they get a cash prize. If it happens to be a 1 through 5, they get $200. If they happen to hold coupons 6 through 20, they get $100. And if they happen to have coupons 21 through 50, they get $50. They're going to continue drawing names until they've given away $300. Now, it may go over $300, but they're going to continue drawing until they get to that $300 valuation and stop. So that's kind of the story of what's going on. But at this point, we don't have a question yet. We still need to figure out the question. So to explain how you would conduct a simulation, well, that means they're going to say, hey, we want you to start going from left to right, and we're going to have to talk about assignment, etc. Using the random number table below to estimate the distribution of the number of prize winners. Okay, so here's what we're looking for. At the end of time, we're looking at the number of prize winners. We're not looking at how much money was given away. We want to know how many people won prizes. So that's the question I need to answer. All right, if you answered how much money was given away, that's not going to get you credit, or not going to get you full credit. If you get full credit, we're going to have to go back and run this thing or explain how we're going to determine how many prize winners there are. But when I look at this and I go, you know what? I have numbers 1 to 50. And I also see a 21 there. Well, I don't know any way to represent 21 as a 1-digit number. And have 1, etc. So basically, I'm going to need to use 2-digit numbers just because there's no way for me to do this as a 1-digit number. And so I'm sitting there going, okay, well, I'm going to keep it simple and use what they are assigning. They said 1 to 5 represents 200. And so I go 1, 2, 5. But those aren't 2-digit numbers, and I need to make them a 2-digit number. That means I have 01 to 05. And they're going to represent 2-digit numbers, and here's what I came up with. I would assign 01 to 05 a $200 valuation, and 06 to 200 a $100 valuation, and 21 to 50 a $50 valuation. Now, if I had more room, I would have made these a bullet point list. All right, I would make a bullet point list because that's a lot easier way to go. I would skip 51 to 99. Well, those are obvious because 51 to 99 we're not using. We always have to make sure we address 0, 0. In this case, we don't need 0, 0, whether that represents 0 or whether that represents 100. We don't need it. So we need to make sure we always address not only the values that we're using, which is 0, 1 to 5, 6 to 20, 21 to 50. Those are the ones we're using, but we're ignoring 51 to 99 and 0, 0. Those are essentially nothings. They don't exist. Now, they show up on the random number table. That's why we have to address them, but we're not using them in the simulation, so they don't count for anything. Then I've done my assignment, all right? And remember, it's like, okay, so we read the problem. We identified the question, which is the number prize winner. We're going to keep going and repeating drawing names or numbers until we have $300. The trial ends when we get to $300. And now we've made the assignment. And we've talked about, we have not yet talked about duplications. So we needed to make sure we talk about duplications. And we also need to make sure that we talk about how we're going to run it, which is going to be from left to right. Well, in the next sentence, working from left to right, I would select 2-digit numbers, and we said 2-digit because we're working with these values right here. So I'd select 2-digit numbers, skipping any duplicates, all right, or ignoring duplicates. Or we could have said in our assignment list, duplicates are not allowed, and we could have done it there, and that would have been fine. Until the valuation was greater than or equal to $300. All right, so we're going to keep going until we got to $300. I would then count the number of 2-digit numbers between 0 and 1 and 50, which would be the number of prize winners. So if you want to say, I would count the number of prize winners for that trial. To increase accuracy, I would run the simulation 20 times. They didn't tell you how many times to run it. If they don't, just use 20 or 30 or some other number. It doesn't matter. So I'd run it several times or a bunch of times and find the average. And that's the last thing we need to do is make sure that we find the average number that could be expected for the simulation. So at that point, I've talked about everything. All right, I've done everything on how to run it. We know how to run it. The next question is, and this will be a full credit response, and you should have all this information in some form or fashion. Your sentences are going to be different than mine, but nonetheless, this is what needs to be there. It says perform your simulation 3 times. That is, run 3 trials of your simulation. Start at the leftmost digit in the first row of the table and move across. Make your procedure clear, and this is really important. Regardless how you do this, make your procedure clear so that someone can follow what you did. You must do this by marking directly on or above the table. Report the number of winners in each of your 3 trials. Well, they told us that we were going to be running 3 trials. And one of the things that I want to say that's really important about this is if I have enough rows on my table, if I have enough rows, it's nice to have a trial stop. Trial 1 start here, trial 2 start here, trial 3 start there, if I have enough rows. And on this particular problem, we do. So if everything works out well, this trial 1 will start at the beginning, trial 2 will start at the beginning here, trial 3 will start at the beginning over here. That's not always the case. And on the next example, we're not going to have enough rows, and we'll talk about how to do that. Now remember, we said 0 to 1. Excuse me, we said 0, 1 to 0, 5 is 200. We said 0, 6 to 20 gets us 100. And we said 21 to 50, those numbers get $50. And we're going to continue until it sums up. Everything else with skips, and we're going to continue until these values sum up to $300. So here we go. The first 2 digits, that's a 72. Well, that was a skip. Then we have 74. That is also a skip. Now, this is a little bit weird, and we stretch across here. We see a 91, and that represents a skip. The next value I see is 33, and that's a winner. How much does 33 win? It's in the 21 to 50, so this gets us $50. Then 47, that's a winner. That gets us another $50. 65 is a skip. Then we get to 03. 03 is a winner, and that earns $200. Now, please remember, 50 plus 50 is 100, plus 200 is 300, so this is $300. That is the end of trial 1. All right, so that's the end of trial 1 right there. Now, I'm going to go ahead and start making my table. You can make it at the end. I generally like to run a trial and just make it. So here we go. We're going to make this really, really simple. Trial. Number of winners. Well, trial 1 had 1, 2, 3 prize winners. We had 2 who won 50, 1 who won $200. All right, so the number of winners for trial 1 is 3. All right, beginning trial 2, 81, that's a skip. 63 is a skip. Stretching across, 83 is a skip. 65 is a skip. 66 is a skip. 42, winner, winner, chicken dinner. And they get $50. 70 is a skip. 93 is a skip. 37 is a winner, that gets $50. 17 is a winner, that's $100. 59 is a skip. 94 is a skip. 31 is a winner. Notice I had to bridge across. They're getting $50. And then 20 is also a winner, and that's a $100 winner. Well, 50 and 50 is 100. Now we're at 200. Now we're at 250. Now we're at 350. All right, so this is the end of my trial 2. And let's talk about that real quickly. We obviously exceeded the $300, but here we didn't have enough. We were at 250 here. We got over to here and we got to 350. So that particular week, we're giving away $350, and that's the trial 2, and we count up our number of winners. We have a 50, a 50, a 100, a 50, and a 100. So 1, 2, 3, 4, 5 winners. So trial number 2 had 5 winners. All right. One thing I didn't address is the reason they have these spaces on the table is just to make it easier for you to read. If you just have a long list of numbers, it's easy to get lost. So the reason for the spaces is to make it easier to read. Okay, the next one, 38. Hey, we started off with a winner. That's a $50 winner. Then we have a 44. That's also a $50 winner. Then we have a 94, which is a skip. Then a 64 is a skip. We go, oh, 38's a winner. And then we're like, oh no, that's a duplicate. Duplicates are not permitted. So that's a skip as well. We didn't get to count 38. We can't have it happen twice because we said in our explanation that we were going to skip any duplicates. All right. Then we have 91 being a skip, 57 being a skip, 79 is a skip, 01, excuse me, not 91, 90 is a skip, 19, I messed that up, 19 is a $100 winner. And then we have 07, which is also a $100 winner. Sorry, that looks bad. So 90 is a skip, 19 is a $100 winner, and 7 is a $100 winner. Well, there's $100, there's 200, that's 300. So this is right here marks the end of trial 3. And trial 3 had 1, 2, 3, 4 winners. And when we total that up, we end up going 3 plus 5 is 8, plus 4 is 12. So we end up with an average of 4 winners, prize winners. So our simulation says, hey, we're going to have an average of 4 prize winners. Now I'm going to address something real quickly. If this had come out to be a decimal, like 4.2, we would say, hey, on average, we expect to have 4.2 prize winners. And you're like, well, wait a second, we can't have a 0.2 person unless something severely went wrong. Well, that's true, but as an average, we can. So as an average, we can say, on average, we expect to have 4.2 prize winners. So my conclusion, based on the simulation above, I would expect there to be 4 prize winners a week. And that right there would have been adequate, because that answers the question. We have 4 prize winners, and that was the question. So based on the simulation, I would expect there to be 4 prize winners. Turns out I could have also taken care of the valuation, and I would expect a payout of about $370. You didn't have to address the money because they didn't ask you about it. If you included the money, nothing is deducted. You don't lose points. You don't get extra points for including it either, but it's not wrong. However, if you only address the money and didn't address the prize winners, you're not going to get full credit, because the question was specifically about the number of prize winners. So make sure that you are answering the question. And here the question was about the prize winners, and on average, we'd expect to have 4 prize winners a week. Right, we will do another simulation in the next video.